we will now implement a no-waiting algorithm that can trim the past, and in this case we will be using a FIFO reliable broadcast. So here's an implementation of causal broadcast algorithm using a FIFO broadcast. So let us look first at the specification of a FIFO reliable broadcast. So we have the two usual events, the request event, which is a broadcast, and the indication event, which is delivery. And here is the FIFO delivery property. The FIFO delivery property says that every process PI must deliver every message from a source BJ in the source's send order. So let us see this now. So if PI broadcasts a message M1 before it broadcasts a message M2, then no correct process delivers M2 unless it has already delivered M1. So we have this property, and then we have the properties of reliable broadcasts, the properties that we know. So here is the idea of using FIFO reliable broadcast to implement causal order broadcast. And it depends on the reliability properties of the FIFO broadcast. So assume now that we use a FIFO reliable broadcast instead of reliable broadcast. And if we go back to the no waiting algorithm, we see that each process PI reliably broadcasts the message which consists of the past and the new message M. So this is, we are now putting them together. Now assume two consecutive broadcasts by PI. So this is the first broadcast by PI. It broadcasts past M1 with the message M1, and we call this L1. And then it broadcasts another message, M2, with the current past at its local state now. And we call this L2. And of course, because we are using FIFO delivery, every correct process delivers L1 before L2, and this is by the FIFO delivery. But now look to these two pasts. If you look to it, you can see that L1 is a prefix of L2. It means that at the time when any process delivers L2, it has already delivered a prefix of that, and that is L1. Therefore, the sender, PI, needs only to broadcast the difference between these two lists. Okay, so how we change the algorithm then? We just make sure that each PI needs to keep track only of the messages between two consecutive broadcasts. So after you broadcast, you reset this list, and then you accumulate messages until the next broadcast. So this is the basic idea, and now let us look at the algorithm in detail, and it is very simple. So here is our algorithm. We are implementing a reliable causal broadcast using the FIFO reliable broadcast. And now, what is the difference? We have, when you initialize the state of the causal order broadcast component, we have only to initialize it with a list that is empty. initially. And this is the list that keeps track of the messages between two broadcasts. Now, what do you do when you want to perform a causal order broadcast? You send what you have in that list L plus the message you want to send. So that is what you send. So M is the last element on that list that you send. And then you basically reset that list. And of course, we do that to store only the new deliveries. Now, whenever a process delivers a list here, that's by FIFO order broadcast from process PI. So what it does, it basically goes through that list in ascending order and checks if the message is not delivered, then it will deliver the message. It will add the message N to the delivery set. And if that message is not stored on the local list, then it appended to the local list. And that is basically the algorithm. So it's extremely simple. Now I will just let you think about the following question. The deliver set is a set of all delivered messages. But can we now trim the deliver set? I leave this for you. It can be done, and it can be done so that it will be quite efficient.